Welcome, everyone. We're about to dive into a chemical messenger well, it's basically the body's on switch. It controls just about everything, from your muscles to your memories. And to kick things off, I've got a little riddle for you.
Yeah, I know it sounds like a weird setup for a joke, right? A cosmetic, a weapon of war, and something you buy at the pharmacy before a cruise. What could they possibly have in common? Well, it turns out they all mess with the exact same incredibly powerful system in your body.
The common link? It's all about this one little molecule, acetylcholine. We'll just call it ACH for short. You can think of it as one of the body's most critical mail carriers, a neurotransmitter that delivers urgent messages between your nerves and your cells.
Okay, so if we want to understand how we can hijack this system, for good or for bad, we've got to start with the basics. We need to see how it's supposed to work. And really, it all boils down to the life cycle of just one of these ACH molecules. And it's a super fast life. It all happens in the blink of an eye, really. There are 4 basic steps. First, it's made inside the nerve. Then it's stored up, ready to go, and released when a signal comes in. Third, it zips across a tiny gap and latches onto a receptor to deliver its message. And finally, boom, it's destroyed, instantly. This clears the way for the next message. Talk about efficiency, right? And this diagram really lays it all out for us. You can see the whole journey. Up top, in the nerve ending. That's where ACH is born and packed up. Then it's released into that little space, the synapse, and it connects with the receptors on the other side. But you see that little guy labeled ACHE? That's the real hero of our story today. Think of it as the off switch. It is absolutely critical. Yeah, that off switch, that's an enzyme called acetylcholinesterase. Let's stick with ACHE. It's perfectly positioned right there in the synapse, ready to pounce. The second ACH delivers its message, ACHE swoops in and just obliterates it. Why? Because without it, that signal would just keep firing and firing and firing, and that would be total chaos.
So this leads to a pretty interesting thought, doesn't it? What happens if we start messing with this finely tuned system? I mean, what if we could jam that off switch? What if we could stop it from working and just crank the volume on that ACH signal all the way up?
Well, in the world of pharmacology, we basically have 2 main ways to do this. We've got our signal boosters. These are things that either pretend to be ACH, or, you guessed it, they block that cleanup crew. And then we have our signal blockers, which just camp out on the receptors so the real ACH can't get through.
All right, let's talk about turning the signal up first. We'll look at a group of drugs called anticholinesterases. Now, their job sounds complicated, but it's actually super simple and incredibly powerful. All they do is inhibit or block that ACE enzyme, our off switch. And when you block the off switch, the signal just keeps on going. The ACH hangs around